Number 9. A county realty group estimates that the number of housing starts per year over the next 3 years will be given by H of R equals 200 divided by 1 plus 0.08 R squared, where R is the mortgage rate in percent. Where is H of R increasing and where is H of R decreasing? Now, before we begin this problem, we should talk about the domain of this function in two ways. One way is algebraic, the other is contextually. Algebraically, we have to worry about the denominator being 0, but this denominator would never be 0 because when you square any number, it would be positive, and therefore we could never get a -1 to add to this 1 to make a 0 denominator. So that's not a problem. The problem is if R is a rate, as in a mortgage rate, it has to be bigger than 0. No bank is going to give you a 0% interest rate, and no bank is going to give you a negative interest rate. So the first thing we need to note on our number line is that our values for R have to be from 0 to infinity. So if we get anything that's negative, that's not going to be part of our answer. Wouldn't make sense. And remember, when you put your critical values or critical numbers on your number line, you put the values where the derivative is 0, the values where the derivative doesn't exist, and the values where the original function doesn't exist. Up until this point, we've only worried about those values that we find algebraically where the function isn't defined. But in this case, we have to look contextually and think about it. All right, so we know we're looking for values that are bigger than 0. So the next thing we have to do is we have to find our derivative, h prime of R. Now, there are a couple of ways to do this. One is to rewrite it. H of R is 200 times 1.08 squared, 08R squared, that is, to the -1. Now, if you do that, you can use the power rule and the chain rule. I doubt you're going to think about that, though. So we're going to find the derivative by using the quotient rule, even though when we take the derivative of the numerator, it's going to be 0. So remember, when you're doing your quotient rule, you always start and end with the denominator. So it's going to be the denominator, 1 plus 0.08 R squared times the derivative of the numerator, 0, minus the numerator, so minus 200, and the derivative of the denominator, 0.16 R. All of that is to be divided by 1 plus 0.08 R to the second raised to the second. So to clean this up, we notice that this is just 0. All right, that whole thing is 0 because you're multiplying by this 0. So that's going to give us -32R over 1 plus 0.08 R squared, all squared. So -32R is our numerator. 1 plus 0.08 R to the second power raised to the second power. Now we're supposed to determine the interval where it is increasing. Now, remember our original number line said that we're only interested in values from 0 to plus infinity, because it wouldn't make sense for an R, a rate of mortgage, to be negative. However, when you plug in values such as -10 and +10, you'll find out that the rate of change is positive on the left of 0 and negative on the right of 0. So in the context of our problem, this function is never increasing. Now, if we weren't looking at it in context, it would be increasing from -infinity to 0. But because that's not part of our problem, we just say it's never increasing. Determine the interval where it is decreasing. Well, we know where it's decreasing. It's negative on this side. Look, if I put a positive number, a number bigger than 0, this numerator is going to be negative. This denominator is going to be positive because we're squaring everything. So it is decreasing on the interval from 0 to infinity.